All right, guys, welcome back. First lesson, we're going to talk about simplifying radicals. Let's go ahead and talk about what we need to do in order to simplify radicals. Radicals are just square roots, so I'll just put that right there. And we can have any number in there. We'll just put a variable for any number. Okay. When you're simplifying radicals, you got to know about prime numbers. Okay, prime numbers are numbers that are only their factors are only 1 and itself. So let's take the first prime number. It's 2. It's the only even prime number that we have. All the other prime numbers are odd. Because if you think about 2 being a prime number, you think about 4. 4 is divisible by 2. Okay? If you have a number that is divisible by a prime, it's called composite. We just want to deal with prime numbers. So I'm going to write the first 5 or so prime numbers. 2, 3, 5, 7, and 11. Okay? Now, I'm going to change some colors here. I don't know what color I'm going to pick yet. Let's look at an example of simplifying a radical. Let's do something like square root of, let's go 42. Okay? Square root of 42. I don't know exactly what it's going to be yet. You can't just punch it in on a calculator. Okay? We want to keep it in radical form. Okay? So we're going to focus on keeping something in radical form. Now, the easiest way to me to kind of simplify radicals is take the number that we have, 42. I'm going to go to a different screen here. And I'm just going to find the prime factorization of that number. This is stuff that you've done way back in 4th, 5th, 6th grade, stuff like that. And you're just going to break it down. I set up power or prime factorization as this right here. I start with 2. I know 42 is divisible by 2. And I just write whatever 42 divided by 2 is there, 21. And then I ask myself, can 2 divide 21? No. What's the next prime number that we have that will divide 21? Now, if you remember our list, 2, 3, 5, 7, 11, you know that 3 goes into 21. So I'm going to take 3, put it right here, and I'm going to ask myself, well, how many times does 3 go into 21? Well, it goes in there 7 times. Now, what we have here in our prime factorization is all prime numbers. Do I have any duplicates? No. Now, if I wanted to expand, let's go back to the square root of 42. Square root of 42, we had square root of 2 times square root of 3 times square root of 7. That's not a 7. All right. I don't have duplicates of anything. That's okay. All right. If you don't have any duplicates, what you want to do is expand it out just like I did here, and then take it back to its original form. Just to show that you know the prime factorization, and there's not more than 2 square root of 2's, or 2 square root of 3's, or 2 square root of 7's. There's only one of each. If there's only one of each prime number, it shows up in your prime factorization. It's kind of just like expand it and then go back to the original form, compress it. Kind of like me when I'm trying to put on a belt. Yeah, that you could have laughed at and roll your eyes. But let's look at a number that kind of has duplicates to it. Let's look at square root of 80. All right. Square root of 80. Let's do our prime factorization. Now, I like doing this because I always used to call it upside down division. Some people like the factorization tree. I don't care which one you use. Just get me the prime numbers. Okay? 80 is an even number. What's my one and only even number that's a prime number? 2. So I'm going to start off with 2 and start doing the prime factorization of 80. 2 goes to 80 40 times. Well, I can keep rolling with 2 because 2 divides 40, right? Okay, that's 20 times. Okay, now we already got duplicates there. We got 2 2s there. Okay, and then I'm going to keep factoring. I can keep using 2. 2 goes into 20. 10 times. I can keep using 2. 2 goes into 10 5 times. Now, all my numbers outside here are prime, which is good because that's what we tried to do. We're trying to do the prime factorization to simplify the radicals. Now, I'm going to expand it out. Sit there and said, let's write square root of 2 for this 2 times square root of 2 for this 2. And I'm going to keep doing that. I got a total of 4 2s anyway. And then I got times, I'm going to have to make some room here, times square root of 5. Okay, I'm just going to erase my work there. It'll be in the video. You can stop, pause, rewind, sit there and say it, grab you some popcorn, stuff like that. Now that I broke it apart, any duplicates that I have, what that means is when you duplicate something, you got 2 of. Well, square root of 2 times square root of 2 is just 2. Okay? Well, this square root of 2 times square root of 2 is just 2. It is what it is. Okay? Now, I don't have any duplicates of the square root of 5, so I'm just going to bring it down here. Now, at this point, okay, these two numbers right here, even though they're the same, I can do one thing to them to kind of simplify it even more. Treat the square root of 5, just leave it alone. Just bring it down. That's going to be part of your answer. With these two numbers here, I'm going to combine them. Well, what's 2 times 2? 4. Boom. That's what I want as an answer. It's in radical form. Radical form means square root. I want this radical sign in an answer. I don't want you punching in square root of 80 and giving me 8.9 or 9 something. I don't know what it is off the top of my head, but that's probably close to it. This is simplifying the radical, and they both are the same. This will equal 4 square root of 5. Okay?